Welcome to our channel dedicated to exploring the rich history of science, technology, engineering, and mathematics, or STEM. In today's video, we will be delving into the fascinating world of sonic booms. Sonic booms are a powerful and often misunderstood phenomenon that have captivated the imaginations of people for decades. From the thunderous roar of a supersonic aircraft to the subtle ripples of sound waves, sonic booms have a complex and diverse impact on our world. Join us as we dive deep into the history and science behind sonic booms, exploring their physics, effects on human health and infrastructure, and the innovative techniques used to mitigate their impact. So sit back, relax, and let's take a journey through the history of sonic booms. What is a sonic boom? Sonic booms are a fascinating and important topic of study due to their potential impact on human health, wildlife, and infrastructure. A sonic boom is a loud sound that occurs when an aircraft or other object travels through the air faster than the speed of sound. This phenomenon has been studied for many years, as it can cause hearing damage and other physiological effects in humans exposed to it. In addition, sonic booms can also have a negative impact on wildlife, particularly marine mammals and birds. The potential damage that sonic booms can cause to buildings, bridges, and other infrastructure is also a cause for concern. Therefore, understanding the physics, effects, and mitigation techniques associated with sonic booms is crucial to developing effective policies and regulations to reduce their impact on society. Physics of sonic booms. Sonic booms are created when an object travels through the air faster than the speed of sound, which is approximately 343 meters per second at sea level and 20 degrees Celsius. Sound waves are created when a disturbance, such as an object moving through the air, causes the air particles to vibrate, producing a series of compressions and rarefactions. The speed of sound is determined by the properties of the medium through which it travels, such as temperature and air pressure. When an object exceeds the speed of sound, it creates a shock wave, which is a type of compression wave that travels through the air at the speed of sound. The shock wave is characterized by a sudden increase in air pressure and temperature, followed by a rapid decrease in both as the wave passes. The pressure and temperature changes associated with a shock wave create the loud sound known as a sonic boom. Several factors can affect the intensity of a sonic boom, including the size, shape, and speed of the object producing it. Larger objects tend to produce more intense sonic booms than smaller objects, and objects with complex shapes can create multiple shock waves, increasing the intensity of the boom. The speed of the object also affects the intensity of the boom, with faster speeds producing louder booms. In addition, atmospheric conditions, such as temperature and humidity, can affect the propagation of sound waves and the resulting intensity of the sonic boom. Effects of sonic booms. Sonic booms can have various effects on human health, wildlife, and infrastructure. Exposure to sonic booms can cause physiological effects such as hearing damage, which can be permanent in some cases. Studies have also shown that repeated exposure to sonic booms can lead to high levels of stress, anxiety, and annoyance, which can have a negative impact on mental health. Sonic booms can also have a negative impact on wildlife, particularly marine mammals and birds. Studies have shown that underwater sonic booms can cause stress, behavioral changes, and physical damage to marine mammals. Birds can experience disorientation and other behavioral changes when exposed to sonic booms, which can impact their ability to navigate and find food. In addition, sonic booms can cause damage to buildings, bridges, and other infrastructure. The intense pressure changes associated with a sonic boom can cause windows to shatter, walls to crack, and roofs to collapse. This can be particularly problematic in areas where there are large concentrations of buildings or where there are historical or cultural landmarks that need to be protected. Therefore, it is essential to understand the effects of sonic booms on human health, wildlife, and infrastructure to develop effective policies and regulations to minimize their impact on society. This can include establishing noise limits for aircraft, developing mitigation techniques to reduce the intensity of sonic booms, and conducting further research to better understand the long-term effects of exposure to sonic booms. Sonic boom mitigation techniques. There are various techniques used to mitigate the effects of sonic booms. One approach is to use noise barriers, such as earthen berms or walls, to reduce the intensity of the sonic boom. These barriers work by absorbing or reflecting the sound waves produced by the aircraft, reducing their impact on surrounding areas. Another technique is the flyover technique, which involves modifying the flight path of the aircraft to minimize the impact of the sonic boom on populated areas. This approach is particularly useful for military aircraft, where the flight path can be adjusted to minimize the impact of the sonic boom on nearby communities. Aircraft design modifications can also help reduce the intensity of sonic booms. For example, NASA has developed a concept called the low-boom aircraft, which is designed to create a softer, more gradual sonic boom by distributing the shock waves along the length of the aircraft. This design approach reduces the intensity of the sonic boom, making it less disruptive to people and wildlife. Regulations and policies also play a critical role in mitigating the impact of sonic booms. The Federal Aviation Administration (FAA) has established noise standards for aircraft to limit the impact of sonic booms on the public. These standards include limits on noise levels for different types of aircraft and flight paths. Additionally, the FAA has restricted supersonic flight over land in the United States since 1973, except for certain military and government flights. Future directions and conclusion. As technology continues to advance, there are exciting opportunities for further research on sonic booms. One potential direction for research is the development of new technologies and designs to reduce the intensity of sonic booms. For example, there is ongoing research into the use of active noise control systems to cancel out the sound waves produced by aircraft and reduce the intensity of the sonic boom. Another direction for research is the impact of sonic booms on wildlife. While some studies have been conducted on the effects of sonic booms on marine mammals and birds, more research is needed to fully understand the long-term effects of exposure to sonic booms on wildlife populations. Furthermore, as supersonic flight becomes more common, there is a need for continued research to understand the impact of sonic booms on human health and infrastructure. This research could inform future policies and regulations related to supersonic flight, and help to ensure that the benefits of faster travel are balanced against the potential risks to public health and safety. In conclusion, this thesis has explored the physics behind sonic booms, their effects on human health, wildlife, and infrastructure, and techniques for mitigating their impact. While significant progress has been made in understanding and reducing the impact of sonic booms, there is still much to learn and discover in this field. Continued research and innovation will be critical in ensuring that the benefits of supersonic flight are realized while minimizing its impact on the environment and public health. Thank you for watching this video on sonic booms and their impact on human health, wildlife, and infrastructure. We hope this video has helped you to better understand the physics behind sonic booms and the techniques used to mitigate their effects. If you enjoyed this video and want to see more content like this, please subscribe to our channel and hit the notification bell to stay updated on our latest uploads. Remember, sonic booms are a complex topic, and there is still much to learn about their impact on the environment and public health. Continued research and innovation will be critical in ensuring that the benefits of supersonic flight are realized while minimizing their impact. Thanks again for watching, and we'll see you in the next video.